Modern artificial intelligence functions as a high-speed generator, capable of producing photorealistic art, drafting software code, and providing complex solutions in seconds. But there is a specific paradox in this technology. An AI can accurately describe Albert Einstein's theories of relativity, yet the way it is built prevents the machine from observing the universe and rebuilding those foundations of physics from scratch. This scatterplot models modern large language models, which predict the next data point in a sequence. They operate on statistical prediction, mapping relationships between known ideas, but remain limited by their training data's boundaries. The system interpolates. It fills in the gaps between existing human knowledge. It cannot move into the empty space to develop a new concept that hasn't been described before. While today's algorithms mimic human knowledge with high fidelity, their internal structure does not function like a scientist. This structural limitation has significant consequences as we deploy these systems into military environments. Global defense programs are currently integrating AI for battlefield analysis and autonomous drone coordination. The technology is also expanding into domestic spheres, driving mass surveillance systems and providing automated medical diagnoses. When these systems make a decision, they do so through a black box. A black box model relies on billions of mathematical weights that are opaque to human observers. If the machine makes an error in logic, we cannot audit its reasoning because it doesn't possess explicit definitions for the ideas it uses. To reach a safe form of artificial general intelligence, or AGI, machines need more than just larger datasets. They require an architecture that allows them to explicitly define and verify their own reasoning. Independent researcher Keith De Cesare has proposed an architectural framework designed to address this lack of transparency. His protocol suggests adding a specific conceptual layer to current AI designs. The first layer uses neural networks as sensory inputs, ingesting raw data to identify correlations. Second, clustering algorithms chop this into distinct pieces, converting messy data into discrete tokens. Third, the definition builder agent takes these tokens, creating a formal definition describing their relationship. This agent bypasses fuzzy probabilities. It forces the system to write an explicit entry in its own internal conceptual dictionary, creating a structured foundation for its ideas. Symbolic reasoning engines then use these definitions to build mathematical models. Finally, a metacognitive layer tests those models against real-world data, discarding any theory that fails to produce accurate predictions. This cycle, observation, definition, theory, and testing, theoretically transforms the AI from a pattern predictor into an active, iterative discoverer. The mathematical necessity of this definition layer becomes clear when we look at how AI agents communicate in a network, or swarm. Without strict definitions, a swarm suffers from semantic entropy. The agent's meanings fragment, and the network collapses into hallucinations. The definition builder agent introduces a structural constraint, pulling the chaotic agents into a smooth catenary curve, the stable U-shape of a balanced chain. This curve represents a semantic equilibrium. It forces every agent in the network to agree on shared, explicit definitions, rather than relying on inconsistent guessing. This mathematical stability is the foundation required to ensure that advanced AI systems do not lose their grip on the physical world. In 1687, Isaac Newton published the Principia. He took thousands of fragmented observations of motion and compressed them into universal mathematical laws. The De Cesare protocol replicates this process within a machine. It provides a pathway for the AI to move from observing patterns to acting as a system that can author its own laws of nature. By creating an explicit conceptual dictionary, this architecture makes the system's reasoning visible to human operators. If an AI makes a medical diagnosis or rejects a loan application, engineers can open the architecture and read the specific definitions it used to reach that conclusion. The path to safe AGI relies on this kind of technical transparency. It ensures that when machines begin writing their own theories about the world, humanity can still read the ink.